The problem was quite clear, especially since I joined DSR. I realized we were sitting in front of the laptop for 8-10 hours, and I really like stretching and I really like moving. So sometimes I would get up and I would just do stretches. And I was joking that this is very important and I'm gonna scream, like I'm gonna come on your screens and scream at you so that you stretch. So this kind of started as a joke that then I realized was actually a big problem. So then I ended up doing a project about it. And I realized that most of the apps that are on the market, they are quite passive, which means that they don't really show you which exercise to do, which I thought is very interesting because sometimes when you're in front of the computer, you don't have time to really think about what to stretch, how to stretch, because you're in the move, you're coding. So I thought I would do something that's a bit more active, something that sees you and then can also recommend you based on your particular bed posture, how to stretch. So my little app, what it does, first it detects a good posture, and then it catches you in slouching pose, or if you're leaning forward, or you're also I realize when I'm coding, I really do this a lot. So this was like a kind of like a last additional piece of it, which still needs a bit more pump up. But anyway, so after 5 minutes of me sitting in a bed posture, there is an alarm that pops on the screen and that tells me which exercise I could be doing. And at the end of the day, I should also be getting a full summary when the app is actually developed. So what I used for this is this virtual transformer called Dino version 2, which is from Meta. And first it takes some image, then it just on 14 by 14 patch goes through the image, does a convolution. So in the end, I get one embedding for each patch, and then it goes through a transformer. This transformer kind of gives the points for each patch, and in the end I get the picture that has 384 numbers. That is kind of a fingerprint of each image, which means that I can identify each image based on this 384 little points that I get for each image. And then this classified image is going to a linear regression, which then classifies this already classified image to my identified groups of bed posture, which is slouching, head forward, and then frowning. This was my biggest limitation to get the data set working, which was quite hard because I didn't want to use synthetic data and I wanted to catch people in their original bed postures. So I went through YouTube and I scraped the YouTube and I went through all the vloggers that you can see who were coding, live coding, or sitting in front of the computer, a lot of game streamers. So I kind of like had to go all these nerd people who were doing their work in front of the computer. And first I had to hand label the images into my already identified classes. So first I created like folders for 3 different groups of the bed posture, and I would just drag the pictures myself before the model learned what I wanted for it to learn. And then in the end, I wrote a Python script that would go to the YouTube through the YouTube video and would take a picture every 3 seconds. And if the picture identified a bed posture, it was already assigned to already grouped folder. So then in the end, didn't have to drag and drop my pictures. So I ended up. This is the numbers of my. Classes. As you can see, it's a bit imbalanced because it's really hard to get these pictures going, especially with a bit of limited time that we had here for the project. And this is I really tried to have the F1 score a bit above 70, which I managed to do, again, for the limited time. And for the training, I had a held out test set, which meant that you can see that for the test set, I had like separate images that were not included during training to avoid the data leakage. And this is the 3D visualization of the embeddings that I told you, 384 embeddings that each image has. It kind of like you can visualize them in the space. And this is the visualization which should be a bit slow, but I mean, you can still see like different colors are different classes, and more far away they are from each other, it means that the classes are more distinguished and model learned better, which you can see in some cases it's not the case because you need more data, but in some cases we do have it. So how does this work? So I use Docker, which has two parts, front end and back end. In front end, the browser opens, it looks at your camera and your posture, and then takes a frame every 250 milliseconds or so. And then it sends to backend to Docker through via fast API, and then we run this already trained model on my laptop. So it's already all internal. Your data doesn't go anywhere, and we classify it, and then you get the output prediction of which posture it is. If it's normal, you get a thumbs up, and if it's bad, so on and so forth. And we can see this in action. So I start the camera, and this is, you see now the brain of you see me, and this is you see, I'm in a good posture. It says great posture. You can see, right? Yeah. And then I'm gonna try to slouch. And it says slouching detected. And here I decrease the time. Usually I want like maybe a minute in a bad posture before the alarm comes. But here now we should be getting an no. Let's wait for another 6 seconds. And I don't know why it's being so sensitive. Let's try. But you can see how kind of like precise the model actually is to detect the posture. It just doesn't pop up the exercise because it's a separate link that I had to like, okay, this is a bit cheesy. If I keep it this way, and then you do an exercise, and then I also had to go to YouTube and made GIFs of the stretches that I thought was useful when you're sitting on so this is one of it. And then you can click a stretch, and then you can do like, so my biggest thing was data limitations and together the data. This is also, it doesn't really show well, right? But it's a 3D posture person that I created in Blender, but then I thought I didn't have enough time for the presentation because it's really hard to detect a posture in 3D mode, and most of the models are not able to detect the 3D posture, which means like if I want to show my head in front, it doesn't really see the 3D, like the distance between my neck and my head when I'm facing camera in front of me. So this is the biggest data limitation. So I thought one of the interesting ways to solve it could be with the 3D person, but I didn't have enough time. But this could be something that I can implement in the future. And you can also see my QR code for LinkedIn. Kind of abrupt end, but thank you for listening.